Hello and welcome. We're going to go over this problem today, square root x. So given a non-negative integer x, return the square root of x. Round it down to the nearest integer. The returned integer should be a non-negative as well. You must not use any built-in exponent function or operator. For example, do not use pow, or in C++ or x star 0.5 in Python. So let's get an understanding of this question first. So we have inputs, non-negative integer x, and then the output is square root of x rounded to the nearest integer and rounded down. And so let's look at some of the examples here. So if x equals 4, then the square root of 4 is 2. So we have a return of 2. If we have the square root of, if we have x equals 8, square root of 8 is 2.8, 2.82842 dot 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 dot. Since we round it down to the nearest integer, then 2 is returned. So so the output is 2. And so that's a basic idea of what we're getting at here. So let's go on to the next stage of our UMPIRE method to solve this problem. So we have match. So similar problems are like problems using binary search or other math formulas. So like here, we could use the Huron's formula to solve this problem, but we're not going to really apply binary search actually, so that's a faster solution. So we're going to apply, so for plan, we're going to apply binary search to solve the problem. So let's implement this solution. So we want the base cases first. So the base cases are if x equals 0 or x equals 1, then we have a return of x. And then we want to start, or we want to start the left-hand side at 1, and we want to end at x divided by 2. So while start is less than, maybe I should say it's less than equal to, or one left is less than equal to right. We want to execute the midpoints. So we want to label the midpoints, and then if the midpoint times the midpoint is equal to x, so if m is the square root, then we want to return m. And then if m times m is less than x, then we want to look at the left-hand side. Or we want to look at the right-hand side. So we set the left-hand side of or the left interval brackets to m+1, and then we store the answer as the midpoint, and then if m times m is greater than x, then we want to look at the right-hand side or the left-hand side of the bracket. So we want to store the right-hand boundary element as m-1. So then after we're done with this binary search algorithm. We want to return the answer, so that's it. Okay, so this is an answer for the square root problem. So let's look at Python tutor for review. So we're going to step through this function. So the input element is 81. So I'm going to store 81, and then we're going to check to see if x equals 0 or 1. It's not. So we store L equals 1, R equals 81 divided by 2. And then if L is less going to R, which it is, so we're inside the interval, and so we get the midpoint of the interval. And if the midpoint times the midpoint is equal to x, then we return n, and it isn't. So we go to the lift statement where we check check to see if it's in the left hand or right hand side of the interval, and it's on the right hand side. It's on the left hand side. So we go down to r equals n minus 1 and look at the left hand interval. And then while L is less going to R, so we're going to do this over again. And so we get the midpoint of the next interval on the left-hand side, and then we check if the midpoint is equal to, if midpoint times the midpoint is equal to the answer to our input integer, and it's not, so we check to see if it's on the left or right-hand side of this interval, and then we see that it's on the right-hand side or on the left-hand side. So we enter r equals n minus 1. So we keep on doing this, and this time we see that the interval that we land on is on the right-hand side. And so we enter answer equals m. And we continue doing this until we update all the intervals, and we have a return value of 9 at when the 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 m hits 9, and it equals it or m times m is equal to x, which is 81. So we exit and we have 9 as the answer. And so that's the solution or for a review of the square root function. So now let's review, evaluate this problem. So this is an O log x time complexity. And since we're using binary search to do this problem, and the space complexity is going to be O log or O1 because we don't use any extra space, auxiliary space, that is, okay? All right, so thanks for watching this um, uh, step through this problem square root x. Bye.